Introduction: Structural Engineering, Transportation and Geotechnical Engineering, Hydraulic and Hydrology Engineering, and Environmental Engineering collectively embody the diverse facts of civil engineering. In this broad field, this specialized branch collaborate to design, build, and manage the physical and natural elements that define our surrounding. Structural engineering focuses on creating robust and stable structure, while transportation and geotechnical engineering optimize movement on land. Hydraulic and hydrology engineering address water dynamics, ensuring effective water management, and environmental engineering strive to harmonize human activities with the environment. Together, this discipline form the backbone of civil engineering, shaping infrastructure that is not only functional but also sustainable. In this simple yet essential convergence, this engineering branch contribute to the development of resilient and eco-friendly solutions for rapidly changing world. Next is today's agenda. First, introduction, subfield of engineering, the themes, objective, summary, and the last one is bonus question. Next is subfield of engineering. First one is structural engineering, second transportation and geotechnical engineering, hydraulic and hydrology engineering, and the last one is environmental engineering. This video project was completed with two combined teams, the first team and the second team. The first team consisted of Azamuddin, Putri Nurin, Muhammad Izwan, Nur Najiha, Lim Zhangzuan, and Alif Shahmi. While the second team was Osama, Irfan Hakimi, Ifa, Nuhaliana, and Waiki. Next is objective. The first objective is explain and discuss the subfield of civil engineering. Second, explain and describe the four assignments. Third, summarize all the four assignments and unite as one. And the last one is answer bonus question in video.
I am Putri Nurin Nazla and I want to present you about structural engineering. Structural engineering is a subfield of civil engineering that focuses on the design and analysis of structures such as buildings, bridges, and towers. Structural engineers use their knowledge of material science, mechanics, and mathematics to ensure that structures are safe, stable, and durable. They work closely with architects and other engineers to design structures that meet functional requirements. This is a drawing that shows the structural system of the building. This figure shows that these are what the structural elements are, such as column, slab, beam, or foundation. Foundation is a base of a structure that rests on the ground and transfers load from the building to the soil. The foundation must be designed to support the weight of the building as well as resist external forces such as wind and earthquake. There are various types of foundations such as shallow foundation, deep foundation, and pile foundation. This is what structure element is. Structure elements are the basic building blocks of a structure that give it stability, strength, and support. These elements are designed to transfer load from the upper level of the building to the foundation, while providing stability and resisting external forces such as wind, earthquake, and other natural disasters. The primary structure elements in a building are the foundation, slab, and column or beams. So this is a column. Column is the vertical structural element that support beam, girder, and other elements of a structure. They are designed to resist compressive forces and are typically made of steel, concrete, or wood. Columns can be either rectangular or circular in cross section and are often spaced evenly throughout the structure. Beams are horizontal structural elements that span between columns, girder, or wall. They support the weight of the structure above and are typically made of steel, concrete, or wood. Beam can be either solid or hollow and are usually rectangular in cross section. Lastly is about slab. Slab is flat horizontal element that provides support and stability in a building structure. They are typically made of concrete or other materials that can be either solid or reinforced. Structure slabs serve as a base for floors, roof, and other part of building that designed to transfer load from the building to the foundation too.
Now I'm going to talk about the transportation and geotechnical engineering. So the transportation engineering is a branch of civil engineering that involves planning, design, construction, maintenance, and operation of transportation facilities. Then the primary goal is to ensure the safety, efficiency, and sustainable movement of people and goods from one place to another. So here we can see 8 roles of the transportation engineer. And the first one, the transportation planning. Then it includes analyzing the traffic pattern, population growth, and land used to develop the long-term plan for an efficient transportation network. So the second one is traffic engineering. And traffic engineering focus on the design and management of the traffic flow so that the traffic will move smoothly and prevent from the traffic jam. So the third one is highway engineering. So obviously they must deal with designing and the construction of the highway so that they can ensure the vehicle in the highway can move in a very safety condition. So the fourth one is public transportation. So public transportation they will involve in uh this planning for the public transportation so that they have more shuttle bus enough or more train enough so that the movement of people will be very efficient. So the fifth one is railway engineering. So the railway engineering, they have a very important role in design and the maintenance of the railway system, and they will also need to plan the route or schedule of the trains to make sure the convenience of the public transportation options. So the sixth one is the airport engineering. So airport engineering, they must ensure the facilities in the airport is still in a good condition, and the terminals they should plan in a very good way so that they can they can operate the air transportation in a very safe way. And the seventh one is the water and waterway engineering. So waterway engineering involves the planning and design of water transportation systems such as port, harbors, and navigator waterways. So transportation engineer uh, is working on optimizing the movement of goods through river, canal, or coastal areas. So the last one for the roles of transportation engineer is the intelligent transportation system. It involves the use of technology to improve the efficiency and the safety of transportation system. So we include the integration of information, communication, and control technologies to manage the traffic flow and enhance the transportation operation. Okay, next, I'm going to talk about the geotechnical engineering. So the geotechnical engineering is a branch of civil engineering that focus on the study of behavior of earth material such as rock, soil, and groundwater and their interaction with structure and infrastructure. And the goal is to assess the subsurface condition and provide recommendation for the design and construction of civil engineering project. Now is a key aspect of the geotechnical engineering. So the first one is site investigation. So geotechnical engineer should conduct site investigation to understand the characteristic of the subsurface material. And the second one, foundation design. One of the critical role of geotechnical engineer is to design the foundation of the structure so that the 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 foundation is strong enough to support the infrastructure. And the third one is stability analysis. So they should they should access they should assess the stability of slope so that they can analyze the factors such as soil strength, groundwater condition, and slope geometry to determine the potential risk of the landslide and recommend appropriate stabilization measures. And the fourth one is retaining wall design. So retaining wall design, in situation where changes in elevation are necessary, such as in road construction, geotechnical engineers design the retaining wall to support and stabilize the soil. So the design takes into account the lateral earth pressure exerted on the wall and ensure the stability against the potential failure. So the big one is ground improvement techniques. So ground improvement techniques, in some case, the engineering properties of soil may need to be modified to meet the project requirement. So the geotechnical engineer will recommend ground improvement techniques such as compaction, grouting, or soil reinforcement to make sure the soil is stable enough and got strength, stable enough and got strength to uh, for a construction. So the last one is tunneling and underground structure. So geotechnical engineering are involved in the design and construction of tunnels. So they they will they will access the soil and rock conditions to make sure the appropriate tunneling methods and provide the support system for applications.
Hi, my name is Muhammad Izwan and I will continue the presentation about the hydrology engineering. Hydrology engineering involves the application of engineering principles to manage water resource with a primary focus on the study of water movement, distribution, and behavior in the environment. These fields play a crucial role in addressing various water related to challenges including floods, drought, water supply, and water quality. This is the water waste treatment process. Wastewater is any water that has been adversely affected in quality by human activities. This includes domestic, industrial, commercial, and agricultural activities. Effective wastewater management is vital for several reasons. It helps to protect our water resource, prevent pollution, and ensure the health of well-being of the both humans and the environment. Let's move to the flood control. Flood occur when water exceeds normal levels, inundating land and properties. They can result from heavy rainfall, storm surge, rapid snowmelt, or a combination of these factors. There are different types of flood control measures, including structural and non-structural approaches. Structural measures involve physical infrastructure like dams and levees, while non-structural measures focus on planning, land use, and early warning system. Dams and reservoirs are vital components of flood control. They regulate river flow, store excess water during heavy rainfall, and release it to gradually to prevent the downstream flooding. The climate change. Climate change refers to long-term change in temperature, precipitation, and other atmospheric conditions on Earth. It primarily driven by human activities such as burning of fossil fuels and deforestation. The main contributors to climate change are greenhouse gas emission, carbon dioxide, methane, and nitrous oxide trap heat in the atmosphere, leading to a warming effect. The major sources including the burning fossil fuels, deforestation, and industrial process. Lastly, the water cycle. The water cycle, also known as the hydrological cycle, is the continuous movement of water on, above, and below the surface of the earth. It involves the various processes that transform water between its liquid, gases, and solid states. This is the key of the water cycle process. First, evaporation, the conversion of liquid water into water vapor due to heat from the sun. Second is condensation, the transformation of water vapor into tiny water droplets to forming clouds. Third, the precipitation, which is the release of moisture from clouds in form of rain, snow, sleet, or hail. And the lastly is a runoff, the flow of water over the Earth's surface, collecting in rivers, lake, and ocean. So that's all from hydrology engineering.
Now, let's move to another part, which is environmental engineering. My name is Muhammad Alif Shami bin Muhammad Izam, and today I'll be your presenter. There's 9 things that I want to talk about today. The first thing is what, the second thing is key aspects, third, fourth, and fifth, and sixth. Also the key aspects, but more detailed. The seventh is importance, and the eighth, I want to do an ICE presentation about another group that do their assignment. And for the last part, I'll be making the conclusion for my presentation. First thing first, what? What is environmental engineering? Environmental engineering is a specialized field of engineering that focuses on applying scientific and engineering principles to protect and improve the natural environment. The primary goal of environmental engineering is to address and solve environmental problems to enhance the quality of air, water, and soil, to manage waste in a sustainable manner. Environmental engineers work on projects that aim to mitigate the negative impact of human activities on the environment and promote sustainable practice. Here are some key aspects in environmental engineering: water quality and treatment, air quality management, waste management, environmental impact and assessment, EIA, renewable energy, environmental monitoring, climate change mitigation, sustainability, regulatory compliance, and last one, research and development. Actually, there's more key aspects in environmental engineering, but today I will share 4 with you guys. Key aspects: water quality and treatment. Environmental engineers design and implement systems for the treatment and distribution of drinking water. They develop strategies to manage and protect water resources, including rivers, lakes, and groundwater. Second, key aspects: air quality management. Environmental engineers work on controlling air pollution by designing and implementing systems for emission control, such as scrubbers and filters. They assess and manage air quality to minimize the impact of pollutants on human health and the environment. Next, key aspects: waste management. Environmental engineers design and optimize systems for the collection, transportation, and disposal of solid and hazardous waste. They explore ways to reduce, reuse, and recycle waste to minimize environmental impact. Key aspects: environmental monitoring. Engineers use monitoring tools and technologies to assess the environmental impact of various activities and to ensure the compliance with regulations. They analyze data to understand trends and make informed decisions about it. Now, let's talk about the importance of environmental engineering. The first thing, public health protection. Next, water resource management, air quality improvement, waste management and recycling, sustainable development, biodiversity conservation, climate change mitigation, disaster preparedness and resilience, compliance with environmental regulations, research and innovation, ecosystem protection, resource conservation, pollution prevention, community resilience, educational outreach, global environmental diplomacy. Now, I'll talk about Harriet Ward University Malaysia, which is assigned to Group 7 from another section, and they shared to us about it. Harriet Ward University Malaysia is an outstanding international branch campus, reflecting its Paris institution dedication to global education. The campus architectural brilliance, sustainable initiatives like Malaysia First Green Roof, and use of advanced technologies showcase a forward-looking mindset with a diverse environment, strong industry connections, and a commitment to academic excellence. The university equips students for success in today's fast-forward world. Let's jump to the conclusion. Environmental engineering is vital for public health, managing water resources, improving air quality, and promoting sustainable development. In shorties, they play a really important thing and really close to us. It plays a key role in biodiversity conservation, climate change mitigation, and disaster resilience. Environmental engineers ensure compliance with regulation, drive research and innovation, and contribute to global environmental diplomacy.
My name is Nur Najah binti Abdullah. I will continue the presentation with summary and bonus question. Now, I will sum up all the 4 engineering disciplines. Generally, structural engineering involves the design, analysis, and construction of structures to ensure that they can withstand loads and environmental conditions. For example, buildings, bridges, and other infrastructure. Second one, environmental engineering. It's application of engineering principles to protect and improve the environment in order to meet the health standard that's safe for all life. For example, air quality, waste management, and pollution control. Hydraulic and hydrology engineering. Hydrology deals with the flow of fluids, particularly water, and its application in engineering systems, while hydrology involves the study of water in the natural environment, including precipitation, runoff, and groundwater. For example, it can be used in water supply systems and drainage systems. The last one, transportation and geotechnical engineering. Transportation focuses on the planning, design, and maintenance of transportation systems. For example, roads and highways, while geotechnical deals with the behavior of soils and rocks. For example, it can assess the stability of foundations, slopes, and earth-retaining structures. As a student of civil engineering, we are encouraged to understand all these 4 civil engineering disciplines so that we can communicate more effectively with colleges, clients, and facilitating teamwork while handling projects in the future. For the bonus question, the problem chosen is air pollution. Generally, air pollution refers to man-made emissions that are released into the atmosphere. Air pollution is said to be dangerous because it gives huge consequences to humans and environment. For employees who work regularly on construction sites, there is an increased risk of them developing health complications such as cough, lung cancer, and asthma. Other than that, people who live nearby construction sites may also experience the effect of air pollution because the air pollutants are spread by wind to the surrounding area. As well as the consequences to human health, we also need to be aware to environmental health. Plants and animals struggle to thrive as a result of this contamination, which causing a loss of biodiversity. While construction activities can cause significant amount of air pollution, there are fortunately some ways to reduce these impacts. Number 1, water suppression systems. Implement the water spraying system to control dust emissions at construction sites can help to settle particulate matter and reduce its dispersion into the air. Number 2, cover the material piles. Cover stockpiles of construction materials will prevent wind erosion and the release of particulate matter. Number 3, enclosures and barriers. Erect physical barriers or enclosure around construction activities contain dust. This can include temporary wind barriers and enclosing construction zone with mesh or fabric. Number 4, proper waste management. Implement proper waste management practices to reduce the generation of airborne particles. This includes covering and securing waste materials during transport. And the last one, dust control chemicals. Use dust control additive or chemicals on exposed surfaces to suppress dust. These chemicals can help in binding particles together, preventing them from becoming airborne. However, many employers of construction companies still cannot afford all the technology meant to prevent air pollution in construction sites. Therefore, engineers are given wide exposure about knowledge of sustainability in order to solve the problem of air pollution in the future. That's all from us. Thank you.